Hello and welcome to the Age of Gaming. In this video, I'd like to go over the differences between positive and negative logic or signaling using my KIM-1's input and output ports here. Everybody understands positive logic. It's very simple. You turn the light switch on, the LED comes on. You turn it off, it turns off. But I'm going to go over a little bit more than that. I'm going to discuss the advantages and disadvantages and the simple differences in wiring, positive or negative logic, and finally the programming aspects, as well as taking a look at the input and output port on your actual computer to see what's going on inside your computer. So let's turn this on and get started. All right, hit reset here, and the first thing you do with your KIM-1 is you go to address 17FA, and you enter your interrupt vector. So I'm going to go data 00 plus 1C, 00 plus 1C. All right, then next thing I'm going to do is I'm going to go straight to the input port and show you how this is, take a look at how this is wired up. It's positive logic, so all of my dip switches are all up here and going to ground, so we have a 0 on our input port. Now you see all the LEDs are on the output port. We'll get to that next. So this is the input port. Everything is 0 because we have everything grounded up here. Now the next address, 1701, is actually the port A data directional register, and that's a 00, which makes this all inputs, which is what we want it to be. Now the next address, 1702, is our actual output port, and you can see 3F in there. It won't let us put that 4 over there, so that's why we have 3F, but everything is turned on, and you can see that here on your output port. Now the next address, 1703, is your actual port B data direction, and you can see it's all inputs, so these lines are actually just inputs floating high and turning on all the LEDs. So let's make this an output port by hitting data and then FF, and you see all the lights went off. Okay, and now let's take another look at that, where we got address 1700, which is our input port. They're all zeros. And what happens if I flip a switch? You can see the input port changes to a 01, or a 02, or a 04, or, oh, you're not back up, 08. And if we go on, it goes to 10, 20, 40. If I hit the right one, nope, I hit the wrong one. 40 and 80. Okay, and that's very simple to understand. 1, 2, 4, 8, 10, 20, 40, 80. Simple logic. That's one of the major benefits of positive logic or signaling is it's very easy to understand, and you can see it right here on your input ports. And the same goes for the output ports. These output ports are wired where a positive signal on one of our output lines is connected to the anode of these LEDs, and the cathode is going to ground. So as soon as you get a positive here, your LED lights up. So let's take a quick look at that. We'll go to address 1702, which is the output port. You can see everything's 0, and we can simply enter right here a 01 and turn on an LED, or a 02 and turn on the next one, a 04, a 08, a 10, a 20, and it won't let us do that last one. It won't do a 40. You see how it goes back to 0? I press 40 and it goes back to 0. And even if I try 80, it goes back to 0. So one of the things you got to know is you cannot use port B pin 6 at all. You just can't use it. And port B pin 7 is actually kind of a shared IRQ port. So I'm assuming that's why it doesn't work. But you can see how simple input logic is. You put in a number, you get something out. It's very simple. The disadvantage is right here as well. You can see how dim these other LEDs are versus that first one, but all the other ones are a little bit dim. And that's because you're trying to drive these LEDs with TTL logic highs instead of tying them straight to 5 volts. So that's the disadvantage of positive logic. I know it doesn't seem like much, but that's the disadvantage. So most of us like positive logic. It's easier to understand. So let's try a quick, easy program. Start at 200, and we'll go into data. And the first thing we're going to do is we're going to load A with the contents of our input port, which is 0, 0, plus 1, 7. And then we're simply going to store A, in our output port, which is 0, 2, plus 1, 7. And then we're just going to jump back around to 0, 0, 0, 2, or 200. And then I'll put a break at the end. So, but first, let me go to address 1702 and clear that out. Go back to address 0200. Now, when I press go, any switch I switch should turn on a light. So let's see if that works. There you go. And you can see how dim the light is here, which is why I believe a lot of people prefer negative logic for that reason. And you can see, or let me turn this one on, and then we'll hit a stop. Now that is switch number 0, 1, 2, 3, 4, obviously. We'll stop, and then we'll go to address 1700. Oops, 1700. 17, there you go. And we have a 0, 8 on our input port. And then we look at the output, and that same 0, 8 is being shown here on our output port. So that's simple positive logic and simple positive logic programming. Very straightforward. So let's take a look at, I'm going to change these switches out for some negative logic switches, and we'll keep this positive for now. So let me get this reconfigured, and we'll take a look at that. Okay, welcome back. As you can see, I've replaced my dip switches with this beautiful 8-bit push button array that I purchased, but I had no idea that it used negative logic, which means basically when no button is being pressed, everything here is a high. And when you press something, you bring it down to a low. So let's take a quick look at address 1700, which is our inputs. You can see everything is high right now. And if I push a button, you see the first bit goes to a 0. So you have FE, then FD, FB, and F7. And here you have E, D, B, and 7 as well. So that's your negative logic on this. And we still have this wired up as positive logic. So if we go on to 1702, we can still enter a 1 or enter a 2. And again, we're still getting dim lights. 0, 4, 0, 8, 1, 0, 2, 0. And again, we cannot put a high on that last pin. It won't let us, or 8, 0. Just won't let us do those last 2 pins high. So this is a negative logic device at address 1700. So now to program this, we're going to have to add one extra command, which is exclusive OR, to change this FF down to a 0, 0 so that we can program it to work correctly. So let's go to address 0200, 0200, and go to data. And the first thing we're going to do is we're going to bring in or load A with contents of our input port at 1700. And then we're going to XOR the contents of that with FF to invert every single bit. And then we're going to store that in our output port at 0217. And of course jump back to 00 plus 02. Now address 0200. Let's make sure I did that right. Load A with the input port. XOR that with FF. Store that at 0217. And loop back to 0200. And that's it. Address 0200. And press go. Now if we push a button, each one of the lights comes on. And again, we're using positive logic on our output, so the LEDs are a little bit dim. And again, we can't do the last ones. Now I'm going to press stop. And then go to our ports. Oh, it would be FB. And then over here, because we XOR'd it, it's actually a 4. So I don't know if I can see very many. I mean, obviously I love the push buttons, but I don't see too many positive aspects of this being negative logic. It's very difficult to, if you wanted to program for a specific button being pushed, you would have to know what that is, or like I did, do an XOR. But I guess that's the point of this one. If you have negative logic, you can XOR with FF and turn it back into positive logic, and well, for the most part, positive logic, so that you can send it out to your output port. So basically, if you have a negative input device, you can XOR it and have positive outputs. So now let's turn this around so that we have a negative input device and negative output devices, and see what the advantages are of rewiring this so that it will use negative logic. Now, the main benefit of that is now you're going to switch these LEDs around, where you're going to send out a negative signal to the cathode of this, and the anode sides are all going to be tied to high. So you should get a brighter LED out of it. So hang on and let me turn this all around. Hello and welcome back again. Finally, now I have my negative logic input, and I've rewired, or basically all I did was turn the LEDs around so the cathodes are now pointing to the output lines, and I have the anodes tied directly to high, which should, produce a much brighter LED. So all I have to do is ground or send a logic low to any one of these LEDs and it'll light up. So let's take a look at that. It might get a little confusing. Again, negative logic just, I guess it's just something you have to get used to. And I'm not used to it yet. So we're first going to turn it on and hit reset. Then we're going to go to address 17FA and enter our IRQ vectors. And then we're going to go straight to our input port, try to 1700, and you can see everything again is in reverse, using reverse logic. So everything's a high until I press a button. We got E, D, B, and F, and E, D, B, and F, or 7. What do I keep calling that? F, 7 and F. Now if we look at output port now we see a B7 or a BF, which is basically a 110. Is it? No, it's a 1011. So as you can see, we're actually able to use port B pin 7 now. So you got a 1011 and the rest are all F's. So everything is high here. So that's why nothing is turned on, because we have the anodes connected over here and the cathodes connected over here. So you need a low to turn on one of these lights. Okay, let's go to 1703. And right now, actually, everything is set up as an input. Once I set it up as an output, the lights are probably, a bunch of lights are probably going to come on. So let's see what happens. Yep, they all came on. Imagine that. All right, so let's go straight into writing a quick program for this. Address 0200. Oops, 0200. And we'll start. And this will be a simple program that we've been doing before. We're going to just, but this time we don't have to XOR it, because this is using negative logic and that is using negative logic. So we don't have to XOR this anymore. So let's go to data and put load A with our input port at 1700. And then store A at 02. Our output port B, and then loop back or jump back to 0002. Okay, we got the program written here, but let's go look at those ports again one last time. Negative logic, everything is high, you press a button and it goes low. Now here's the also interesting thing on our output port. You see the BE, everything's lit up, but you really can't. One of the disadvantages here is you can't just load a 01 in there. Oops, sorry, address 1702 data. You just can't load what you want in there. Actually, they're really bright right now. So let's go to our program at 0200, where we're going to load the input port and then store that in the output port and jump back to 0. Address 0200. And press go. So anytime I hit a button, an LED is going to come on. And again, you can see how bright those LEDs are. That's the primary advantage of negative logic. You see this button, which would be bit 6 isn't working, but bit 7 is working now. Because you can send a low out on PB7, you just can't send a high to PB7. So that's kind of an advantage, but not much of one. But the primary advantage is that negative logic allows you to tie your devices to the 5-volt rail and, really energize your LEDs or whatever else other device you might have hooked up out there. So let's take one more look at our program. Let's press this button, and we're going to have to keep it pressed, and then I'm going to hit stop. Then we're going to go take a look at our ports. Here's FB, because I have the third switch turned on or off, depending on how you look at it. And then go to our output port, and you can see it still shows BF. So that's the disadvantages. It's not simple logic that you can look at your ports and excuse me, tell what's going on. But the advantage is, being able to wire everything up to the positive rail and send a logic low to activate it. Well, that's it for now. Hopefully you learned a little bit about positive and negative logic and the advantages and disadvantages of both, and how to use a negative logic device with a positive logic setup by XORing all of your inputs so that it'll come out correctly on your outputs if it's positively wired, or if it's negatively wired, you just pretty much program it straight. Just input to output and you're good. Anyhow, have a great day.